All right. In this section, it says 6a, complete the table for f of x equals x squared and g of x equals x squared plus 3. Then graph each function on the same coordinate grid. Well, we've already done f of x equals x squared. That was on the previous page. So we have 9, 4, 1, 0, 1, 4, 9. Now, g of x says x squared, so this column, plus 3. Well, this number plus 3 is 12. This number plus 3 is 7. This number plus 3 is 4. This number plus 3 is 3. This number plus 3 is 4. This number plus 3 is 7. This number plus 3 is 12. So now we're going to graph these. Negative 3, 9 is here. Negative 2, 4 is here. Negative 1, 1 is located right here. We have the point 0, 0, 1, 1, 2, 4, 3, 9. This looks very similar to the graph we did earlier. All right, let's take a look at the next function. Function g of x. Negative 3, 12. Negative 2, 7. Negative 1, 4. 0, 3. What looks to have happened here? Well, let's take a look at some things. Where's the vertex of the original function? 0, 0. Where's the vertex of the new function? 0, 3. Where's the domain? All real numbers. Where's the domain of the new function? Again, all real numbers. My range here is anything bigger than 0. So we'll say y is greater, we'll call it f of x. F of x is greater than or equal to 0. Here, my lowest value, though, for my range is 3. So we'll say g of x is greater than or equal to 3, not 0 here. My axis of symmetry is on that y-axis, which is x equals 0. My axis of symmetry does not change for for my g of x either. That's going to be x equals 0 as well. Let's take a look at 7. 7a says complete the table for f of x equals x squared and h of x equals x squared minus 4. So we're going to start off with those same values that we did earlier. 9, 4, 1, 0, 1, 4, 9. Okay? This time we're going to subtract 4 from each time. So we've got 5, 0, negative 3, negative 4, negative 3, 0, 5. And we're going to graph. Well, I can't graph negative 3, 9. That's off my grid. But I can do negative 2, comma 4. And I can do negative 1, comma 1. 0, 0, 1, 1, 2, 4. So I got like this U shape again, right? Looking like such. Let's graph our next one. Negative 3, comma 5. Well, that's here. Negative 2, comma 0. Negative 1, comma negative 3. 0, negative 4. 1, negative 3. 2, 0. And then 3, 5. Okay, let's talk about our vertex. Here we know that our vertex is 0, 0. I can pull this from my last table. We have all real numbers. My range was f of x is greater than or equal to 0. And here we have x equals 0 as my axis of symmetry. Let's talk about what happens when we subtracted 4. My vertex is located at 0, negative 4. We have all real numbers for my x values. For my y values, they have to be greater than or equal to, oops, I can't say g of x because it's actually h is the function's name. H of x is greater than or equal to negative 4. But my axis of symmetry didn't change. It's still along that y-axis. Compare the functions g of x and h of x in terms in items 6 and 7 to the parent functions. Describe any patterns you notice in the following: the equations, the tables, the graphs. My equations, g of x and h of x change the parent function f of x by adding or subtracting a constant. Looking at their tables, the y values of g of x are 3 more than the y values, of f of x, while the y values of h of x are 4 less than the y values of f of x. Okay, let's talk about those graphs. Oh, before I move on to the graphs, sorry. Remember that constant that was added? We had a constant of 3 added and we had a subtraction of 4. Those are the same as these two changes. So the constant was the change in the y values. Okay. Now going to the graph, sorry. The graph of g of x is shifted 3 units up from the graph of f of x, while the graph of h of x is shifted 4 units down from the graph of f of x. The constant was the change in the graph. I should say was the shift in the graph. All right. Let's go to number 9. Let's talk about those vertices. Okay, my vertices went from 0, 0 to 0, 3. And it went from 0, 0 to 0, negative 4. So, uh, g of x has a vertex of 0, 3, which is an increase of 3 to the y coordinate of the vertex of f of x. H of x has a vertex of 0, negative 4, which is a decrease of 4 to the y coordinate of the vertex of f of x. Domain and range. The domain remained the same for all three graphs. The range changed depending on the vertex. Talk about the axis of symmetry for all of them. The axis of symmetry remain the same for all three graphs. The changes to the parent functions in items 6 and 7 are examples of vertical translations. A translation of a graph is a change that shifts the graph horizontally, vertically, or both. A translation does not change the shape of the graph. Number 9, make use of structure. How does the value of k in the equation g of x equals x squared plus k change the graph of the parent function f of x equals x squared? K will shift the graph up or down depending on its value. If k is greater than 0, the graph shifts up k units. If k is less than 0, the graph shifts down k units. On the next slide, you're going to see a debriefing question. Please go ahead and take a moment to answer that, and then we'll move on to the last section for this lesson.